something remarkable has crossed the stars and entered our solar system. Comet 3 I/Atlas, one of only a handful of confirmed interstellar objects ever observed. As telescopes worldwide turn to study this cosmic visitor, one nation stands out for its silence. China. What are their observatories seeing? What data might they already have? And why has there been so little public communication? Today, we explore what is known, what is possible, and what remains hidden. What we know about 3 I/Atlas. 3 I/Atlas, officially designated C/2025 N1, was discovered on July 1st, 2025, by the Atlas Survey in Chile. Its orbit is hyperbolic, meaning it is not from our solar system. It came from beyond. Observations from the James Webb Space Telescope show a CO2-dominated coma with other gases like water vapor, carbon monoxide, OCS, and dust. The CO2 to H2O ratio is unusually high, among the highest ever measured in a comet, and that means it may have an unusual formation history. UV studies from the Neil Gorell Swift Observatory detected OH emissions, a sign of water, even when the comet was still $3.50 from the sun. This is rare. Water typically doesn't show activity that far out. Light curves show modest variation, but the coma hides the nucleus, making it hard to determine its exact shape or rotation. As for its origin, dynamical models suggest it likely came from the thin disk of the Milky Way, but no nearby star has been clearly identified as the source. These are peer-reviewed or preprint-backed findings. They are the facts. China's observational capabilities. To understand what China might know, we need to understand what they're capable of. Tianwen-1, China's Mars orbiter, has been operational since 2021 and is equipped with imaging and scientific instruments. It is capable of observing phenomena near Mars. Media reports suggest that Tianwen-1 was among the orbiters expected to observe 3 I/Atlas, as it passed roughly 30 million kilometers from Mars in early October 2025. China also has ground-based observatories, powerful, well-funded, and active. Chinese astronomers often collaborate internationally, but data release is typically selective and sometimes delayed. There are multiple reasons: review processes, internal publication cycles, and sometimes strategic or political discretion. So, in short, China has the tools to observe 3 I/Atlas, especially during key moments like its Mars approach. What's been reported about China's observations? We do have some indicators that China is involved. The European Space Agency, ESA, included Tianwen-1 in a list of orbiters expected to track the comet near Mars. This is supported by reports from CGTN, China's international broadcaster. But beyond that, media and forums note China's lack of public updates. While NASA and ESA regularly release findings, China has remained relatively quiet. No public images, no spectral data, no high-profile press releases from the CNSA as of this recording. Even though Chinese scientists appear on some preprint papers, their work seems tied to theoretical modeling, not new observational data. So what we can say is this: China is likely observing, has the capacity, but has not publicly released major findings. Why might China be silent? Why the silence? Let's look at possible explanations, some reasonable, others more speculative. Scientific verification. China might be waiting to verify data before public release. Scientific priority. Holding results for first publication advantage is common in competitive astronomy. Instrument limitations. Maybe the geometry wasn't ideal. Maybe the data was too noisy. Strategic communication. China sometimes delays announcements for state policy reasons or media control. Technical constraints. Processing space data is resource-intensive. Delays happen. Avoiding sensationalism. With claims floating around about alien probes, China might be careful to avoid being linked to speculative narratives. Now let's consider what China might already know, but hasn't shared yet. Scenario 1. Tianwen. 1 captures high-res images during the comet's Mars flyby. Scenario 2. Ground-based observatories detect unusual spectral signatures, maybe organics or dust composition anomalies. Scenario 3. Long-term light curve data, revealing rotation or activity patterns that others missed due to poor viewing geometry. Scenario 4. Orbit refinements, measuring tiny deviations due to comet outgassing. Scenario 5. Clues about origin using Chinese analysis of Gaia data or unique simulations. Are these confirmed? No. But are they plausible given China's tools? Yes. If China holds unique data and doesn't share it soon, there are real consequences. Scientific delay. Other researchers can't build on findings they never see. Trust and transparency. In a global science community, trust is built on openness. Fuel for misinformation. When there's a gap in official data, speculation and conspiracy rush in to fill it. Lost opportunities. 3i/Atlas is here now. Observational windows don't last. Imagine the headlines. High-res Mars images of comet jets. Infrared detections of exotic molecules. New models of comet behavior based on unshared data. Anomalous readings unlike anything seen in other comets. These would shift the scientific narrative, and they would raise questions. When did China know this? Why didn't they share it earlier? And what else might be sitting in silent data vaults? When space agencies go quiet, the risks are not just scientific. They're political. They're public. They're global. Science thrives on collaboration. Without it, doubt spreads, credibility weakens, and discoveries lose their power to inspire. We don't have proof that China is hiding something, but we do know they have the tools. They are part of the observer group. Yet, no unique Chinese findings have emerged. So far, there are reasonable explanations, and still, the silence lingers. So we ask, what might still be revealed? What do they know about 3i/Atlas's structure or origin? And how will they choose to share it, if at all? These questions go beyond just one comet. They touch on how humanity shares knowledge, and how much power exists in what is known and what is kept quiet. 3i/Atlas is a visitor from beyond, but what we learn about it might teach us just as much about ourselves, about our science, our transparency, and our trust in what we choose to reveal.